discussing section 4.5, which is graphing lines in standard form. But actually, instead of it saying graphing lines, your paper says graphing equations and inequalities in standard form. So I decided to split that up into two parts. So first of all, how do we graph equations? Okay, graphing line equations in standard form. We're going to find the x and the y intercept as step one. We're going to plot those intercepts on the graph. And we're going to draw a line through those 2 points. So very basic steps. When you have an equation in standard form, you have two options. You could solve for y in graph from slope-intercept form. When I was growing up, that's what we were taught. That you had two options. And we only graphed from standard form like once or twice a year. I did not care for that method. Okay, but now that we have a whole entire unit, and we're seeing the real-life application of equations wrote in standard form, it makes a lot of sense to graph from standard form using intercepts. And a lot of people, once they see this, they're like, oh my gosh, can every equation just be this easy and this quick? Right? So, looking at example number 1, let's take a look here. So the equation is 2x minus 3y equals negative 12. So the first thing you need to do is find an intercept. So like we discussed in section 4, an intercept is when your graph, or where the line would touch the axis. And that means the opposite value is 0. So if I wanted to find the x-intercept here, I would plug in 0 for y. That would leave me with 2x equals negative 12. And how do we solve for x? Well, the opposite of times is divide. So we're going to divide both sides by 2. My x-intercept is then negative 6. My y-intercept, where I'm at on the y-axis, I would have a value of 0 for x. So if I cover up my 2x, what do I have left? Negative 3y equals negative 12. Again, solving for y, I need to divide both sides by negative 3. So now my y-intercept is positive 4. So on the x-axis, I'm going to go to negative 6 and put a dot. On the y-axis, I'm going to go to 4 and place that intercept. Izzy's going to offer you a protractor to draw a straight line if you'd like. Okay? So we're going to, again, step 3, connect or draw a line through those intercepts. Okay? And that is all that we're doing. Finding the intercepts, taking negative 6 and putting it on the x-axis, taking 4 and putting it on the y-axis. Because we solved and found the intercepts. What questions do you have right now from that first example? Okay, so I want you to look at example number 2. $12x plus 6y equals 24. I would like you to take about 30 seconds right now and find both the x and the y-intercept. I want my x-intercept, I'm plugging in 0 for y. I have 12x equals 24. Divide both sides by 12. my x-intercept is 2. Finding my y-intercept, I plug in 0 for x. That leaves me with 6y equals 24. My y-intercept is 4. Again, these are intercepts, so I get to plot these dots on the axis. X-axis 2, y-axis 4, and draw your line, add some arrows. What questions can I answer about number 2? We all caught up? Where's your stuff? Okay. All I could see was the blank side. I was really confused. All right, example 3. 90 seconds, start to finish. Let's see what you got. Alright, so I plug in 0 for y. I'm going to have negative 15x equals 30. Plug in 0 for x. I'm going to have 6y equals 30. My x-intercept would be negative 2. My y-intercept is 5. So I put a dot at negative 2 on the x-axis, 5 on the y-axis. And draw my line and add some arrows. All right, show me on a scale of 1 to 5. 1, I could not do this on my own without your help, and a 5 is I am perfectly capable of doing examples like 1 through 3. Okay, awesome. The great news is, guys and gals, we're going to transition the next 3 examples. What is the difference? Okay. Look at examples 1, 2, and 3. What's the only difference on 4, 5, and 6 if you look at the problem themselves? We have equal signs and then inequality signs. Okay? So we're going to have the same graphing process, but remember what we said last class about inequality signs. Inequality signs, when we have an equation, but now it's an inequality, it's a boundary line. So when we had this worksheet, we had to shade. That's what we have to encompass now. Okay, 2 slight, 1 modification and 1 addition to the steps that we just did. So here they are. We're still going to find the x and y intercepts, so write that down quickly, please. We're still going to plot the intercepts on the graph. But before we draw the line, we have to check to see if it should be solid or dashed. So this is comparable to when we had open and closed circles when we were graphing on a number line. The same rules apply. So less than and greater than signs had open circles because I could not equal that value. That is what a dashed line is going to be. Less than or greater than signs are going to be dashed. Solid lines are going to be less than or equal to or greater than or equal to. Because I can equal the value, I'm going to have a solid line. So we're finding our intercepts and we're plotting them the same as what we just did, but we might have a dashed or a solid line. And the last step is that you are going to shade the true side of the boundary line that you create. Question over here. Oh, no. Okay. All right, so let's go through a couple of examples here. On example 4, I have a less than sign. So if you want right away, you could write down the word solid or dash so you don't forget about that part. So what is this one going to have? Dashed. Okay? So if you want to jot that down off to the side so you don't forget, it's a great strategy. Now, intercepts. When you find your intercepts, this doesn't matter, your inequality sign. So I'm going to go ahead and I'm going to write 5x equals 40, and that should be a y as a big old typo. Change the x to a y next to the 10. All of these problems should have x, y. All right, so we have 5x equals 40, and then we're going to have negative 10y equals 40. So intercepts, the inequality sign doesn't matter because we're still going to be on the axis. So I just go ahead and put equal signs here. So to get x by itself, I divide by 5. So my x-intercept is 8. To get my y-intercept, I'm going to divide by negative 10. And so my y-intercept is negative 4. So again, step 3, we had to decide solid or dashed. We've already decided this is going to be a dashed line. So I'm going to put a dot at x, 8 on the x-axis, negative 4 on the y-axis, and now you want to draw in a dashed line and add arrows. Because we're shading on inequalities, it's really good for your line to stretch all the way across your coordinate plane. Okay? Yes.
Why is it dashed?
Because it's not equal to. It's just
not equal to, it's always going to be dashed?
Yes, whether it's greater than or less than. Same as the open circle on the number line.
What if it's equal to or larger than? Is it still dashed?
So if it has the line under it, it has the possibility of being equal, we're going to make it a solid line. So now, this is the part where we need to shade. When we were on this paper, your shading correlated to your less than or greater than signs because it was real world. We were only in the first quadrant. Now our line can be anywhere on this coordinate plane. So we must test a point. Okay? And to do that, I personally always test the ordered pair 0, 0 because it's the easiest number to plug in, especially when we're in standard form. So 5 times 0 is 10 times 0 is 0 minus 0. So when we test 0, 0, this whole entire side, 5x minus 10y, that turns into 0. Now ask yourself, is 0 smaller than 40? It is. So 0, 0 is true. Put a dot at 0, 0 on your graph and put a T there because that point is true. Okay, and so that is the side of the line we want to graph. Recall that if there's one point on that side that's true, that whole entire side is true. If 0, 0 would have been false based on our inequality, we would have shaded the other side of the line. Okay, so we have 2 more examples to do together. Darn it, I have an X there again. This needs to be a Y on example 5. Please change that X to a Y next to the 3. For pity's sakes, I messed up on all 3 of those. Okay. So we have 6x plus 3y is greater than or equal to negative 12. Find your intercepts. 6x equals negative 12. 3y equals negative 12. What is our x-intercept? Negative 2. What is our y-intercept? Negative 4. Go to the x-axis. Put a dot at negative 2. Y-axis. Put that on the wrong spot. X-axis, negative 2. Y-axis, negative 4. Solid or a dashed line? Solid. Okay, because it has the opportunity to be equal to, we are doing a solid line. Again, because it has the opportunity to be equal to it. Okay? Now, we need to test 0, 0 to see if it's true or false. So I'm going to take 0, 0 and I'm going to plug it in. Again, what we're doing here is 6 times 0 plus 3 times 0, and we want to know, is that greater than negative 12? Is 0 greater than negative 12? Yes, it is. So that's true. Find 0, 0 and put a T on it and shade that side of the line. Again, if that ordered pair is false, then we will shade the other side of the line. All right, example 6. Again, next to the 3, please make that a y. This is what happens the first time you make a document and you don't proofread well enough. Finding our intercepts. We're going to have 1x equals 6, 3y equals 6. What is our x-intercept? 6. 6 divided by 1 is 6. What is our y-intercept? 2. Go to the x-axis. Put a dot at 6. Y-axis, dot at 2. Solid or a dashed line? Dashed. Okay, because it is not equal to. It's setting up a boundary line. All right, so 0 plus 3 times 0. Is 0 greater than 6? No. All right, here's our first time where 0 is false. So shade the other side of the line. Okay? So it depends on where your line is at compared to where 0, 0 is at and where you're going to shade. So we shade the true side of the line.